Hello, this is Mrs. Davis. I'm doing notes for AP Pre-Calculus Lesson 1.12 on transformations of functions. So the first information is just a review, the rules for transformations. So if you have a function and you add a constant k to the back of the function, that's a vertical translation, k units. So plus k is up and minus k would be down. All right, and so you can see they have minus 2 here, so every point was moved down 2. All right, if you add a constant inside the function, f of x plus h, that is a horizontal translation, meaning left-right, negative h units. So if it's plus h in here, it would be left, and if it's a minus h, it would be right. Okay, again, this was moved plus 2, which means you move it left 2, so every point was moved left 2. All right, you have dilations. Those were translations. Remember that word, translation. Translation, translation. Now we have dilations, and we have vertical and horizontal dilations. So vertical dilations are the easiest one. You would multiply by a factor of a, whatever coefficient, and so we would call that one, if a is greater than 0, it's a stretch, and if, greater than 1. Sorry. Shoot, let me erase this, get it back. If a is greater than 1, it's a stretch. If a is between 0 and 1, it's a compression. Okay, so hopefully you remember that. Now if a is less than 0, so negative a, it's reflected over the x-axis, which affects y. So both of these things affect y. So if you look what happened in the picture, they reflected it over the x-axis. So here, and they stretched it by a factor of 2. So y was multiplied, every y was multiplied by 2, and then it was reflected over the x-axis. Now, a horizontal dilation occurs inside the function, so you have f of b times x inside, and that makes you multiply by a factor of 1 over b. So whatever they're multiplying by inside, you do the reciprocal of it. And also, if b is less than 0 in here, inside the function, it's reflected over the y-axis. So all that should be reviewed to you. If not, go find it in your textbook, and it goes into more detail about how to, what those are. And that's true for any function that you have. And so we're going to look at some piecewise functions, and we're going to also be talking about them graphically and then algebraically. And so we're just going to walk through these. These are fairly simple. If you look at what's happening, you have a new function, which is f of x plus 4, and they want you to graph that new function. So that's just a vertical translation up 4. So every point you would go up 4. So here's a point, and you go 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and 2 would be 1, 2, 3, 4. And so it would just be translated up 4, oops, this is a curve, 4 units. All right, looking at this example, this is a horizontal translation, so it's translated it's plus 4, so it's left 4. All right, so every point would be moved left 4. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and down here 1, 2, 3, 4. So coming here and doing like that, and that would be translated left 4. Okay, example 2. We have it moving down. So, translated down 4. So every point would just be moved down 4. So 1, 2, 3, 4. Just do this in your notes so you'll have it. So we're here and down 4. All right, okay. And this is right 4, so translated. All right, so every point is just moved 4. So here we are. Okay. Now, let's do a vertical reflection. So if you look, I have a negative in front of my function, so that means it's reflected. You should be able to write these transformations. This is reflected over the x-axis. So that just means everywhere there was a point, you reflect it over here. So if this was at -4, 3, it would be -4, -3. And 0, 0 is nice because it stays the same. And this would be at 2. So you're looking at kind of obviously it looks like a little fish, but there's your reflection. Okay, now this one puts it all together. We have a horizontal, so we're translated horizontally. Right 2, and then we're reflected over the x-axis with this negative, and then we're translated up 5. All right, so let's make sure that you follow. If it's not specified, sometimes they tell you, and it's different how they want you to do it, in what order. But in the order, it would be order of operations, where the parentheses would be first, then this is a multiplier, and then the last thing you're done is add 5. All right, so we're going to try to do this step by step. Okay, so first we're going to move it right 2. So every place there was, we're going to move it right 2. Okay, so here we are. There's right 2. Now, I'm going to switch colors, and I am going to reflect it over the x-axis. So I am going to have this one here, but at 1, I'm here, back down to 0, and here. So there's my reflection over the x-axis, and then I move the whole thing up 5. So getting my third color, I'm going to go up 5 for each one of these in the purple. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5, 5. So it looks like that. There you go. Oh, I used the green one. Did y'all see me making that mistake? These. I was looking at the green one instead of the purple one, so 1, 2, 3, 4, 5 would be down here. So I didn't do the reflection up here. There we go. Okay, so that's your graph. All right, I'll stop this video there, and we'll do a second video looking at algebraically and using numerics.